Hello viewers, I am Kausalya. Today we are going to see the value of steady state error when the type of input is ramp signal. As we all know, the formula for steady state error is ESS is equal to limit s tends to 0 s into r of s divided by 1 plus g of s into h of s. Here R of s is your input, g of s is the feed forward element and h of s is the feedback element. For unit ramp signal, the value of R of s is 1 by s square. So what is the value of unit step? For unit step, the value of R of s is 1 by s, right? The next step is we are going to substitute the value of R of s in the ESS formula. So here ESS is nothing but this is your formula we had already seen now. The next step, we are going to substitute the value of R of s here. So R of s is nothing but 1 by s square. So I am substituting the value and here 1s get cancelled and the remaining term is 1 by s divided by 1 plus g of s into h of s. So this 1 by s can be written as 1 by s, right? That is the numerator term I am rewriting here. When we write 1 by s, that is this 1 by s can be written as 1 divided by s, that's all. So s into, here this denominator term comes as such here. And the next step is I am going to multiply this s with these terms. So s into 1 becomes s here, right? So s into 1 becomes s plus again s into g of s into h of s. So for this term, when you substitute the value of s as 0, this term becomes 0. So here I had written that one plus, and again I am moving this limit s tends to 0 inside. Why I am not making this term again 0? Because I don't know what is the value of g of s and h of s. It depends upon the problem given, right? So here I am just moving this limit s tends to 0 inside. So limit s tends to 0, s into g of s into h of s. So finally, this expression can be written as ESS is equal to 1 by limit s tends to 0, s into g of s and h of s. So what is the formula? Limit s tends to 0, s into g of s, h of s is nothing but our velocity error constant. So here I am rewriting this entire term by 1 by kV. And this kV is nothing but our velocity error constant, right? The next thing, we are going to find the value of this kV for type 0, type 1 and type 2 system. What is a type 0 system? It is a system with the denominator part whose denominator part will have no s term, right? This is type 0. For type 1, the denominator term will have only one s term. And for type 2, the denominator term will have s square term, right? Now we are going to find out the value of kV for type 0 system. So what is the formula for kV? It is limit s tends to 0, s into g of s into h of s. So what is the general format of representing g of s into h of s? It is nothing but k into s plus z1, z2, z3 and divided by s plus p1, s plus p2 and s plus p3. So here I am going to apply the value of s tends to 0. When you substitute s equal to 0, here we are having an s, right? So when you substitute here, this becomes 0 multiplied by this entire term. So anything multiplied by 0 is again 0. So the value of kV is equal to 0 here. What is the formula for steady state error? Steady state error is 1 by kV. So the value of kV is 0. So anything divided by 0 is nothing but infinity, right? So for a type 0 system, the value of steady state error is infinity. And next we are going to see about type 1 system. So for type 1 system, the formula as such, that is limit s tends to 0, s into g of s, h of s. And again, this is type 1 system, right? So the denominator term should have one individual s term. So while representing g of s into h of s, you see k into s plus z1, s plus z2, s plus z3 divided by, here I am having an s and this s represents the type 1 system, right? So s S into S plus P1, S plus P2 and S plus P3. Here these two S terms cancel each other and finally we are having an expression like this, right? When you substitute S equal to 0, what happens? 0 plus Z1 gives Z1, 0 plus Z2 gives Z2 and here is Z3. Similarly, 0 plus P1 gives P1, 0 plus P2 gives P2 and 0 plus P3 gives P3, right? So here we are having values like that. Finally, the final answer will be a constant, okay, or it may be a number. Constant or number, whatever may be, it remains the same. Then constant is nothing but whose value always remains the same. So here we are having constant as output. So the next thing is, what is the formula for steady state error? It is 1 by kV. So anything by constant is again which will give you a constant output. So the value of steady state error for type 1 system is a constant, right? And next we are going to see about type 2 system. So the formula is kV equal to limit s tends to 0 s into g of s into h of s. And again, while representing g of s into h of s, we are discussing about type 2 system. So the denominator term will have s square term, right? Initially for type 1, it has only s term, and for type 2, it has s square term. So when you substitute the value, this s and s cancel each other, and finally we are having a term s in the denominator. So when you substitute the value of s tends to 0, what happens? That is k into something here divided by, you will be having some z. That is k, and 0 plus z1, z2, z3. Okay, we will be having z1 into z2 into z3. The whole thing divided by, here we are having 0. So 0 into, I am having p1, P2 and P3. So anything divided by 0 will result in infinity. So what is the value of steady state error? So the steady state error is given by 1 by kV, and here the value of kV is infinity. So 1 by infinity is nothing but 0. So the steady state error for type 2 system is 0 when the given input is ramp, right? Hope you understand this terms. Thank you.